Mr. Hong here with another lesson, and today we're going to be starting a new unit, which is 7 point, or I guess just Unit 7, and Unit 7 actually has two parts to it. Usually our parts were either by like graphing or by functions, and like solving the functions by solving for x. This time we're going to be separating the unit, so we have Unit 7. We have two parts. We have exponential, which is also known as, well, I abbreviate as expo, and we have logarithmic, which is called log. And through exponential and through log, you're going to be talking about solving for x and graphing. And for the log side, we're also going to be talking about solving for x and graphing. Know that these two are really the same thing because these are inverses of each other. So coming back to like the last lecture, we talked about adding is to subtracting, multiplying is to dividing. That's not a good multiplication sign. Squaring is to square rooting. And now exponential is the same as log of 2 of x. Now this is the same, these are inverse of each other. So this idea of a new function, they are inverse of each other. And this is where Algebra 2 starts becoming Algebra 2. So to finish off with that introduction, we need to first understand at least one of them. So today you're going to be able to graph a function, well, b to the power of x and log of x, where b is 2 and e, because there's two situations, or I guess multiple. Analyze the key attributes such as the domain, range, intercepts, asymptotic behavior, max and min of a given interval. So let's talk about the graph first. So we're going to be talking about exponential function, and f of x, or y, is equal to a times b of x. And a cannot equal 0, b cannot be a negative number or less than 0, so it has to be at least 1 and above, but b can't equal 1. So really this should have been b is greater than 1. The cool thing about exponential functions is that your y-intercept is going to be, well, your x is always 0, and this is actually going to be a. So whatever your a is right here is going to be right here. So if a is 1, then your y-intercept is 1. The domain, if I'm talking about this blue graph right here, or even like this red graph, we're going to be talking about the blue graph majority of the time. The graph for the blue line and the red line have a domain of all real numbers, which is also negative infinity to infinity. But range is a little bit different because, as we can see by this and this end right here, it's approaching 0, but it's not touching 0, as in it's getting very, very close to it. So we can write an interval notation of 0 to infinity for the blue. And this is the blue. I guess I should just write that. 0 to infinity. And the red graph is also 0 to infinity. Because it only reaches, like, or it doesn't come on this side of the graph, right? It's all my values for y are positive. The asymptote, or the line that it can't cross on this graph, is actually this right here. And we can represent that line as y is equal to 0. As in, it cannot cross it, it cannot touch it, all it can do is approach it. And that's why we use brackets here. So make sure to use brackets when we talk about the range on this type of question for range for exponential. Exponential growth and exponential decay. So this unit is a lot of fun because we talk about investments and appreciation, which means growing in value, or depreciation. Like when you buy a car, you drive it off the lot, it's depreciating. That's also known as losing value. So the growth is actually the blue graph, as you can tell. And this is also when A is positive. So that means that if I have a decay, A is negative. Hold on, just one moment. Okay, I'm back. Okay, so let's try looking at this problem together for example 1. So I have graph y equals to 2 to the power of x. And if you don't know how to graph this by hand, you can always say that, okay, my a is, well, it's supposed to be y is equal to a times b to the power of x. So this b to the power of x is actually this right here. So what is my a? In this problem, I don't see my a. So it has to be 1, because 1 times 2 to the power of x is still 2 to the power of x. And my b, that's just this 2 right here. So this is 2. So very simple. I gave you an equation for your y-intercept, which is 0, 1. And the way that I got that is because it's 0, a. And your a is equal to 1. The domain is always going to be all real numbers, so I can write negative infinity to infinity. So let's try graphing this. So if I plug in, if I say x and y, if x is 1, if I plug in 2 to the power of 1, that's 2. So if x is 2, 2 squared is 4, 3. If I do x is equal to 3, I get 2 times 2 times 2, which is 8. So this is going to be like times 2. This is going to be like times 2. So this is going to be times 2. So 4 is going to be 16, and so on and so on. So first things first, we need to graph our y-intercept, which is going to be right here. Let me use a different color. It'll pop out more, like this, then here. Oh wait, this, and then like here, and so on and so on. Sure. I know my end behavior. Like if one half of my graph is going up, that means that my other half is just going closest to 0, like this. Nice. So my range, if it's not touching 0, it's just approaching it. I can't include it, so it has to be parentheses 0 to infinity. The asymptote, since it doesn't, or it approaches 0, but it doesn't touch it, that means that my asymptote is y equals to 0. Because it's horizontal, horizontal goes like left and right. As in, you look at the ocean horizon. So this is horizontal. So is this a growth or decay? A great question to ask yourself right here is, as x goes towards infinity, does it go up? If yes, it's a growth. As in, the more you have, or like, let's think of it as like time. If you have something for a long time, does it gain more value or does it lose its value? So if it gains value, it's a growth. But if it's a no, then it's a decay. And the word decay comes from like when your body decays, you're losing your weight and like all of your, yeah, you understand. So growth is when you're growing up. This graph is going up, is going towards the north side. So this is a growth. So lots of things that we have to look for in this problem. So in Algebra 2, we taught you already how to look for these things in graphs that are familiar, such as linear, um, even square root you've seen before, quadratics you've seen in Algebra 1. So now we're amping it up by giving you a new graph, and now we're asking you the same questions. So let's try example 2. What is my A and my B in this question right here? Let me like shade this real quick so I can tell myself I need to put a question here for A and B. Okay, A is equal to 3 and B is equal to 0.5 or half. And I can highlight it right here. What do you use this? Green. This is A. And this is B. So I know that if my x or my y-intercept is always going to be 0, comma a. So my a is 3, right? So it has to be 0, comma 3, which is right here. So this is my y-intercept. Zero comma a, which equals 0, comma 3. My domain is still going to be all real numbers, which is negative infinity to infinity. And you see how my intercept is here already? It's above 0. I don't have any pluses or minuses, so I can assume that it's just on the 0 line right here. So it's like this. And I'm just gonna like freeball it like this just because. But this is actually going to be still 0, comma infinity. And my y asymptote is still going to be y equals to 0. I actually messed up here. Now looking at it. Not right. And the reason why that's not right is because when I thought about it, if I have my XY table, and let's say for example I say I have 0.5 is 0.5 to the power 1, that's 0.5. But if I have 0.5 or half to the power of 2, that's half times 1/2. Isn't that 1/4? So x got bigger, right? X became 1. It was 1, but it became 2. But my answer became a half to a fourth. So when I ask this question again, as x goes towards infinity, does it go upwards? Does my graph go upwards? Well, here to here, it went down, or it decreased. Therefore, this must be a decay. Like so. And actually my graph is going to look something very similar to like this. So my range is still y is greater than 0 or 0 to infinity. I just wanted to justify redeem myself before I give you wrong information. Nice. So here comes something special where we talk about something like very brand new, and you're just gonna have to accept it for now because this is the first day. But this is called a natural base. And natural, you're gonna be seeing this word a lot, which is natural base or natural log. And that's when we use the letter E. And E is really like 2 point blah 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 blah. And we use this number very often whenever we talk about investments. It's very applicable to real life where we're gonna have a lot of fun with that. But this graph right here is gonna be, this graph right here is y is equal to e to the power of x. And note that my a right here is still a times b to the power of x, but b is equal to e, so my a is still equal to 1. So look at my y-intercept right here. It's still 0, 1. This function is useful for describing exponential growth and decay. So the significance of E is more like applied in like real world calculations, such as like investments and appreciation of a car, depreciation of a car, your house investment, etc., etc. So what's different between E and having a number for B? Really nothing, because as I look into my graph right here, this is still going north. This is going like dead west, and this is right here going northeast. So since I go west and east forever, my domain is still all real numbers, which I'm gonna just abbreviate like this for note purposes. And my graph right here is still above this this line right here. Like there's nothing over here. Like there's no graph within the negative side of my y value. So my range is still going to be 0, infinity, or y is greater than 0. And the reason why we put y is greater than 0 is because we know that this graph is not touching 0, it's just approaching it infinitely. The y-intercept, or the x-intercept, is still the asymptote, which is y equals 0. And here comes the fun part. The minimum and the maximum of the interval -4, 2. So I know that -4 right here, this is lower than x is equal to 2. As in, it doesn't look like it, but this point right here is less than this point right here. It could be fractional, and it is. And the way that we can calculate that is by y equals to e to the power of 4x. Or e to the power of -4, sorry. So if... Oh, sorry. It's -2? I meant +2. It's +2 right here, like this. So I need to be able to calculate e to the power of -4 and e to the power of 2. And the way that I would highly recommend you do is by using Desmos. So let's try it out. E to the power of -4, which is like 0.0183. I'm just gonna round it up to, which is rounding to 0.018. And this one's gonna be e to the power of 2, which is around 7.389. Sure. Close enough. And this is going to become very useful whenever we're going to be talking about investments. So just keep that in mind. The graph is going to show us a picture of my investment. My investment is something tangible. And this is like the fun part in math where I can talk to you about like my real world expenses. I can talk to you about how to buy a car efficiently. So a lot of applicable stuff. So try to do example 3. I'm gonna be putting some questions up here for now. Let me just wave this camera to indicate that. Okay. I'm gonna go really fast because I don't want to waste your time. So if I draw this graph, it's gonna look like this. My intercept is gonna be here. And the reason why it is because of 0, comma a, which is 0, comma 2. And the reason how I know it's 2 is because this 2 right here. A is equal to 2, B is equal to E. And know that E is like equal, it's like approximately 2 point blah 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 blah. Just to give you a little assurance, yeah, 2.7. So this is 0, comma 2. Domain, still the same, all real numbers. The range, still the same, which is y is greater than 0. The y asymptote, still the same, y equals 0. I don't even need to graph this on Desmos for me to know that. This will stay true for most of the time because think about it. If I had a car, right? And I didn't do anything to it, I just let it sit there. I'm not talking about insurance, I'm not talking about gas, I'm not talking about maintaining the car. I'm just talking about the car itself. Can that car make me pay more money if I've already paid it off? And that's a no. And that's why my y will never go towards the infinity. It'll always be above 0 and it'll shoot up. But I missed the 2. If your investments require you to pay more money for the same amount of investment that you've already paid upfront for full, you're making a very stupid investment. So it's the same question. Minimum and maximum intervals. So I know that this right here of -2 of please change pencils. -2, I know that this is greater or less than this. So this has to be my minimum, -2. So e to the power of -2, which is approximately, and e to the power of 0, which I know that's 2. Or that's not e to the power 2, sorry. That is oh, this is 0, comma 2 because we already found that because when x is equal to 0, y is equal to 2 on the graph because of my formula, which is right here. This right here is from here. So all we gotta do is type this in. Ooh, this is also e to the power of -2 times 2. That is 2 times e to the power of -2. That is 0.271. So yeah, there you go. That's pretty much all you need to know about the attributes of exponential functions. Next time we meet, we're going to be talking about transformations, as in, what if I moved it up, down, left, right, flipped it upside down, blah, blah, blah. So you should be having a Delta Math assignment today. Make sure you answer all the questions in the Edpuzzle to get credit for today, and I'll see you guys next time. Peace.